Welcome to topic 1 for Science 9, and we're going to deal with the concept of static electricity. If we're going to talk about static electricity, we need to revisit the atom. So to refresh your memory, the structure of the atom, here's what we know. We know that atoms contain protons, which are positively charged, and neutrons, which have no charge, and those are located inside the nucleus. Then when we continue to look at the structure of the atom, we see that thanks to the Bohr model that electrons are located outside the nucleus and they hover around in different orbitals. And so this is important when it comes to static electricity and, for that matter, electricity in general, because electrons which are further away can be removed from an atom accidentally through friction or various other methods. And what we know about static electricity is there are substances which we call insulators which hold their electrons quite tightly, and they don't move well through a substance. For example, plastic, cloth, glass. These are good insulators. However, conductors, on the other hand, are substances that loosely hold their electrons, which means that it allows them to move through the substance easily. And so most metals, as you know, are good conductors, which means they allow the electrons to move through the substance. So let's look at this again. Insulators in general, non-metals, hold on to their electrons. And metals don't hold on to their electrons very well, and we call them conductors. But there's a couple other kinds that we want to talk about. Superconductors, which are used in high voltage power lines, what happens is we'll take a metal, which is a conductor, and if we supercool it, that means cool it down to a really low temperature, we can create a superconductor out of it. And semiconductors, like silicon, which is used a lot in computer chips, would be considered a semiconductor, silicon, and they allow some flow of electrons through the substance to help us create electricity within chips, but it's kind of the flow is limited. So let's focus in on insulators for a minute, because they help us understand a little bit more about how static electricity might work. Let's take two balloons, for example. What happens is when those balloons rub together, you can see on the surface of the balloon you've got positive and negative charges, but as the balloons rub, it starts to build up the negative from the yellow balloon to the blue. Now what that causes is the following. That causes this balloon over here in the blue to have an unnaturally negative charge to it. And because this balloon gave up some of its electrons, overall now it has a positive charge because it has less electrons. Oops. And so there's an attractive force now between the two balloons after we've done this friction or rubbing. So how do objects become charged? Well, mostly friction and rubbing. So as I said before, let's look at this. We can take a plastic or polyethylene rod and we can rub it against something like a cloth, and the cloth could transfer some of its electrons to the rod, so the rod is overall more negative than it normally would be. It's not neutrally charged anymore. And if the cloth gives up its electrons, that means now overall it's lost some electrons, so its charge is positive. Now if they join together, there's going to be an attractive force between them. So just as a review, everything we see is made up of tiny particles called atoms. Atoms have protons, electrons, neutrons. They're very different from each other. Usually atoms have the same number of electrons and protons, and we say they're neutral. However, if you rub things together, electrons could move or transfer from one atom to another. And if they have extra electrons, they become overall negative. If they've lost their electrons, they can be positive. So this brings us to why some substances, when this happens, with an imbalance of charges, might attract to each other or repel. So if two things have different charges, they usually attract. So different charges, that means opposites attract. So something, kind of like magnets, something that's overall negative will attract to something that's overall positive. And we also know that if substances have like charges, that means the same, they push away or they repel, like in this picture. So these are two pith balls, and what happens is these light little styrofoam balls with the metal over it, these two will push away from each other because they're both like charges, and these two would attract to each other. Some substances work better than others when it comes to giving up or receiving electrons. So this electron transfer that goes on depends on something called the triboelectric series. And so it looks like this. After several tests, what happened is substances higher up on this scale mean that they have an increased ability to give up their electrons. Rabbit fur, glass, human hair, nylon, wool, etc. They're really good substances at giving up their electrons, letting them go. And something lower down on the triboelectric series is good at accepting electrons. Teflon, PCV pipe. In other words, lots of plastics. Lots of plastics tend to accept electrons. So here's the deal. Let's say you want to generate an electric charge. Well, ultimately, take Teflon and rabbit fur, or even human hands that aren't sweaty and moist. If you put those two substances together and rub them, you're going to create two really charged objects. In other words, the Teflon's going to give up its electrons, or it's going to accept the electrons, and the rabbit fur is going to give it up. So that would be the ultimate way to create a static charged object. Let's come back to this in a minute. Let's talk about how we control this whole static electricity effect. There are three or four factors to prevent or allow static electricity to happen. And one factor is humidity. The drier it is, so if you have dry air, you're going to get greater possibility of the electrons either being given up or accepting. So if you don't want static electricity in your house or in a computer place, then you want lots of humidity. Okay, high humidity and water vapor blocks the transfer of electrons. The second factor is, of course, the type of material, and we already talked about the triboelectric effect. So on the triboelectric effect, there are good substances, or there are substances that are good at accepting electrons, and there are substances that are good at giving up their electrons. Next, of course, friction. The greater the amount of friction, the greater chance or opportunity for electrons to be transferred. And colder temperatures will allow electron transfer to happen more readily. Lightning, believe it or not, even though moisture is involved, is an example of super duper static electricity. So what happens is, as clouds move about, lightning can be generated because the friction between the cloud particles can cause part of the cloud to get extra electrons from another cloud. And all that would have to happen is for the cloud, like in this picture, to run close to the ground and have something that is unnecessarily positive, and an electric discharge would happen in the form of lightning. Gas stations often have had static electricity discharge occur. So this lady actually started a fire by her gas tank because gas vapors are so flammable and volatile. All you need is some gas vapor, and this lady to accidentally, through friction, give a static discharge close to the area. So now some gas stations have these areas that you touch so you can give off any electric charge that you might have built up from your seat. Uh, they talk about going in and out of your car as not being a good thing because what happens is that builds up static electricity from inside the vehicle. When gas stations have big tankers come in, they have actually a grounding rod to prevent any electrical discharge. And when a car is driving on the road, this little rubber device helps to dissipate any buildup of electrons through driving. Let's look at this quick video clip with a few minutes left in my session.
Electricity is a flow of charged particles. These particles originate in the atom. If you have ever studied the atom, you will know that an atom has a compact center called the nucleus. The nucleus contains two types of particles: protons, which have a positive electric charge, and neutrons, which have no electric charge. Small charged particles called electrons exist outside of the nucleus. Electrons have a negative charge and they are attracted to the positively charged protons. The electrons move in high-speed orbits around the nucleus, held close to the nucleus by the strong force of attraction from the protons. You can witness this force by rubbing a balloon on fabric, creating an imbalance of electrons and protons. Small pieces of paper will stand up and jump to the negatively charged balloon. Scientists call this static electricity because the charge doesn't move, it stays on the balloon. Two negatively charged balloons repel one another. The like charges on each balloon repel. This force can cause electrons to move from one place to another. When electrons flow between 2 points, we call this electricity. One of the most dramatic effects of electricity is a lightning strike. Electrically charged clouds release their charge in an explosive flash. A powerful demonstration of electricity. To use electricity, we need to find a way to safely contain and control this flow of charged particles. That is what a battery cell does.
And that concludes my little session on topic 1, static electricity. Next up, we'll learn how current electricity works.